So let me do this with you. Here's our game right now. The first thing I asked you to do is change the title of the window. And you see what the title of the window is right now? It's untitled. If we do a search for untitled, you can see it's right here. And on this line here, it says set title untitled. Now you wouldn't have necessarily known to do that, but now that I've shown you in hindsight, you'll remember that that's a great way to find out. So I'm going to change untitled to something. Turtle attack. That's not very snarky. Okay, well, I couldn't think of anything snarky. What should I write? Oh, that's good. Bad news turtle attack. The bad news turtle attacks. Whatever. Okay, we have a new title. I build it. I like to build after every change. Why? Because if I broke something, I want to know which line broke it. So I build it, I run it. The bad news with a Z turtle attacks. I'm still running. Okay. Next thing I asked you to do is change the size of the frame to whatever you like. Well, notice the very next line was right there, so I would really like to change from 1,000 to 999. And no change is perceptible. That's lame. Let's make some perceptible change. Let's go to 700. So now it'll be squarish. There you go. Now it's squarish. We did that. Next change was make the whole main loop faster by sleeping for shorter amounts of time. So let's go. Where do we put this thing to sleep? Well, no, let's take a nap. Yeah, but you see how take a nap takes a parameter for how long to sleep. We could get rid of that parameter and hard code a value, but we could also change where it's called. Right here it's called take a nap 50. Let's change that to what? 15? I don't know, some smaller number. If you make it bigger, it'll nap for longer. If you make it smaller, it'll nap for less. There you go. Now it's a reasonably fast turtle. Just out of curiosity, how fast is this turtle? So let's do the math. It's sleeping for 15 milliseconds. I better update my comment too, just so I don't have an obsolete comment. There are 1,000 milliseconds per second, correct? If I divide that by 15, this is making the assumption that all of the time is in sleeping and everything else it does takes no time at all, which is not entirely true, but it's mostly true because computers are fast. I'm getting a frame rate of 66 frames per second, so the turtle is moving at 66 pixels every second. If I knew the size of the pixel, I could do a little more math and tell you exactly how many meters per second it's traveling. And in fact, we could make the turtle move with physically proportionate distances if you knew the size of your monitor and things like that, in case you care. If we set it, when we set it to 50, we were moving at a rate of 20 pixels per second, or 20 frames per second, because it was 1 pixel per frame, which stands to reason. If I set this to a 0, the turtle will move infinity per second, and it'll be a blindingly fast turtle, right? In theory, in practice, no, because nothing's infinitely fast. So that'll tell us how long it really takes. Here's the maximum. Well, that almost is pretty much infinitely fast. Well, that just shows you how all the stuff we did doesn't take very long to a modern computer. The vast majority of what it's doing is sleeping. So in fact, if you were to watch your processor's not actually being eaten up by this program. If you were to omit this line and run the program, and you opened up, say, Task Manager and watched the processor usage, it would spike up to 100 because this would be using up your processor. If you have it running on a laptop, your little laptop fan will start going bzzz because it's working really hard. So napping is an important thing to do in a main loop if you don't want your program to drain your laptop battery.
How could I make the turtle face the pointer?
Face the pointer. So you're saying, now he's doing it right, But when I click over here, you want him to turn around and go the other way.
Yeah.
Okay.
And you don't need to go all the way through.
Actually, that leads into something that's coming up very well. The easiest answer is get two turtle images, one that's facing this way, one that's facing that way. Your painting program undoubtedly has a way to flip an image. So it'd be pretty easy for you to make a second image. And basically, when the turtle's going to the right, draw this image. When the turtle's going to the left, draw that image. There might be a method that draws an image flipped. I don't know. You'd have to Google the APIs to find out. But in my opinion, I wouldn't use it anyway, because for example, suppose you have a warrior with a sword in his right hand. If you flip it, now the sword's in his left hand, and that doesn't feel right. And so you have more flexibility to do it right if you mess with the image rather than just flip it. Although you're using that many more bytes of memory. So if we were in the 1980s, I would use the flipped image approach. If we're in the 2010s or whatever we're in, I'd load a second image because who cares, memory's cheap. Okay. The last task I gave you was get rid of this button. So there's that push me button. Let's go get rid of that. I'll search for push me. There it is. Well, I could just get rid of things that use it. And I think that's going to work. Yay, no more button. And the turtle moves. Okay. To my code? Okay. I commented out 4 lines. Here's what I did. In fact, let me show you the way I would really do this. I did too much for you just now. Here's the way a programmer would get rid of that. So now there's a button. I'm going to comment out this button member variable, and I'm going to press build. And now the compiler is going to do all the work for me by finding all the places where something needs to be done. Click here. Oh, that line causes a problem. Goodbye. This line causes a problem. Goodbye. This line causes a problem. Deleted. Now I rebuild. No bugs. Now I'm good. See how I did that? I kind of made the compiler do all the work by removing this member variable, such that anything that references that member variable is going to say, what's a B1? I've never heard of B1. And give me an error message. Did that make sense, or did I say that too fast? Okay, let me say it more slowly. This member variable represents the button. If I remove that button, nothing's going to be able to push the button, nothing's going to be able to handle the button, nothing's going to be able to manage the button, right? So I just remove that member variable, and then I hit build. That's going to find a whole bunch of bugs in my code wherever I used a button. And so that's kind of a quick and easy way for me to find all the places in my code where I used the button. It just happens that these are the only 3 places, but it could be that maybe I used the button in 12 places littered throughout my code, and by simply removing that variable, I've created an error deliberately that I'm using to my advantage to find those places. That was what I was trying to say. Okay. What I'd like to do now is return to our game instructions. I believe we are on step 63. 61, 62, 63. Okay. We've got a turtle walking around. Let me show you what we're building up to. Have you ever seen the Flappy Bird game? You've seen the Flappy Bird game? It came out not too long ago, a few years ago. The author of it made over $1 million off of it. It's not that fancy of a game. There's a bird that flies, there's tubes that it flies over, and that's about it. Well, if that game can make $1 million in modern times, wouldn't it be nice if you could write that app? And if you could, then hey, you could probably make some other app that would make $1 million, and then go and do it. And then at least send me a nice thank you note or something if you get rich off of your newfound programming abilities. So here's some images of a bird I found. I just Googled for flapping bird. It's not a great one. The Flappy Bird's actually cartoony. I didn't want to steal their IP though, or it'd look like I was ripping them off. So, and there's some tubes. And I thought, let's turn this turtle game into a Flappy Bird game. That'd be fun. So go to step 63. And the first thing we're going to do is make the turtle fall by simulating gravity. How much do you know about gravity?
9.8 meters per second.
9.8 meters per second. Okay, that's...
Step out of a perfectly good plane.
Yeah, awesome. That's the principle is gravity pulls things down. So what I want you to do is add a member variable. Well, let me show you this. Let's suppose I come up here to my model update method. And I simply say turtle y plus plus. What does that do? It's going to make my turtle go down, right? Kind of like what gravity does. Whereas my play button's not working. Why is that? That's because I'm still running. Okay, I build, then I run. And he's not moving. Why not? I've got 2 bits of code that are fighting each other right now. My turtle y++ is moving him down, but my destination is at the origin, and so this line right here is moving him back up. And you can't actually see the turtle moving because he moves down and moves back up, and then we repaint the screen, so you never see him move. Okay, so I'm going to now comment out this y stuff. In fact, I'll just comment out all of it. Goodbye, that stuff. Now all my turtle's going to do is move down. He's falling. Whoa. It's not very realistic, is it?